In this video, we want to learn how we can sketch the regions in the complex plane. Our first example is absolute or modulus of z minus 2 less than equal 1. We want to sketch the region for this. But before we start, let me remind you the geometric interpretation for absolute or modulus of a complex number. When we write absolute or modulus of complex number z, what is the meaning of this? Absolute or modulus of a complex number basically represents the distance from origin. So whenever we write absolute or modulus of complex number z, remember this in your head. It shows the distance of that point, which is z, from the origin. So if absolute or modulus of z is the distance from the origin, then absolute of z equals, let's say, 2 represents what? This would be a circle with radius 2. But why? Attention, absolute of or modulus of z is 2. So this means that we are looking for points in this plane, in the complex plane, which this is x-axis and this is y-axis, or you can say this is real axis, this is imaginary axis. We are looking for points in this plane such that their distance from origin is equal to 2. Where is origin? Origin is here. Now we are looking for points in this plane such that their distance from this fixed point is 2 units. If you pay attention, those points are the points on the circle with radius 2. This radius is 2 units. And of course here is 2, here is negative 2, here is y equal 2 or 2i if we suppose it's imaginary axis, and here is negative 2i. Based on the definition of a circle, all the points on this circle, every point you consider on this circle, their distance from origin is exactly 2 units. So this equation shows a circle with radius equal 2. So in general, absolute of z equal to any number. This is equation of a circle with this radius. If here is 10, the radius of the circle is 10. If this number is 1, the radius of the circle is 1. And the center of these circles is at the origin. Now, what about this equation? Suppose we have this equation, absolute of z less than equal 3. So, if we consider the case that absolute of z is exactly 3, this is a circle with radius 3. If we suppose 3 is here, we can think of a circle like this. But we want to know what is the region that this equation shows. Absolute or modulus of z is less than equal 3. So we are looking for points in the complex plane that their distance from origin is less than or equal to 3. And probably you can guess that this equation shows the points on the circle and inside the circle. So this equation represents all the points on the circle with radius 3 and the points inside the circle. Now, what about equations like this, which is given in this question here? Here we have not absolute or modulus of z, we have absolute or modulus of z minus 2. When we have absolute or modulus of z minus a number or plus a number, then this shows the distance from point 2. In general, when we have absolute of z minus z0, this shows the distance from z0, distance of point z from z0. Basically, this is the geometric interpretation for absolute or modulus of a complex number or even a real number. Absolute is defined in a way that always shows the distance. When you have absolute of z, it shows the distance from the origin, but when you have absolute of z minus something, it shows the distance from that number. So absolute or modulus of z minus 2 is the distance from point z to point 2. Now we are looking for points that their distance from 2 is less than equal 1. Where is point 2? Point 2 is here. Attention, this shows the x value. If we suppose this x-axis or real axis and this y-axis or imaginary axis, now we are looking for points that their distance from this fixed point here is less than or equal 1. Those points are exactly on this circle or inside this circle, which radius of this circle is 1. So here is 3, here is 1, and this is also 1, or you can say 1i because we are in imaginary axis. So here we can say it's I or 1i, and here is negative I. So this equation shows all the points inside or on this circle. Remember, we are looking for points that their distance from 2 is less than 1. All the points on this circle, their distance from this point is exactly 1. Let's suppose this point. This distance is 1 unit. Consider this point. This distance is 1 unit. Consider 3. The distance from 3 to 2 is 1 unit. Distance from 1 to 2 is also 1 unit. And the points inside this circle, their distance from 2 is less than 1. So the region that this equation shows is on this circle or inside the circle. This circle, the center of this circle is, what is the coordinate of the center of this circle? The center of the circle is the point 2, 0. And radius of this circle is exactly this number here, which is 1. Let me show you a general equation here. Absolute of z minus z0 in general equal r is the equation. The circle with radius r and the center of this circle is at z0. For example, absolute of z minus 4 equals 3 is a circle with radius 3 and the center of the circle is the point 4, 0. Let me show you a little more complicated example. What about this? Absolute of z plus 2 minus I equal 3, for example. What this equation shows? Note that if we can write this equation in the form of z minus a number, then that point shows the center of the circle. So we have to try to write this in the form of minus. So we factor a minus from these 2 minus I. So to figure out what this equation shows, first I rewrite this in the form of z minus, if we factor a minus, then we have negative 2 plus I equals 3. So this point shows the center of the circle, and this shows the radius of the circle. Let me show you this equation, graph of this equation here. First, let's find the center of this circle. Negative 2, x is negative 2. Y, attention, I means go 1 unit in the y direction up negative 2. This is imaginary axis or y-axis. This is x-axis or real axis. The x is negative 2, so 2 units to the left. I means go 1 unit up. So from negative 2, we go 1 unit up. So this is the center of our circle. Now, radius of the circle is 3. So, draw a circle with this center here, and the radius of the circle is 3 units. So something like this would be the region. This is not a perfect circle, I know, but you can understand. So this radius of the circle is 3 units. Before I show you more examples, let me prove for you why absolute of z minus z0 equals r shows a circle with radius r and center of the circle is z0. We know we talked about geometric interpretation for absolute, but here I want to give you a proof that whenever we have equation like this, how we can prove for ourselves that this shows a circle. Let us start with the definition of absolute or modulus of z minus z0. z0 is a complex number, so we can suppose z0 is basically x0 plus iy0. And we can suppose z, which is a complex number in general form, x plus iy. So here I want to try to show that this equation shows a circle with radius r and center z0. To do so, the center of the circle, which is z0, can be written in the form of x0 plus iy0, because any complex number can be shown in this form. And instead of z, we substitute x plus iy. If we substitute these in this equation, then we have absolute or modulus of x plus iy minus x0 minus iy0 equals r. We can write this equation in the form of x minus x0 plus I times y minus y0 equals r. Attention, we group the real parts together, x minus x0, and then we factored I to group the imaginary parts together. This should be clear how from that equation we got this equation. Now, remember the definition of modulus or absolute of a complex number. Absolute or modulus of this complex number here is a square root of x minus x0, the real part to the 2, plus imaginary part to the 2. It should be equal to r. Now, raise both sides of this equation to the power of 2. Then we have x minus x0 to the 2 plus y minus y0 to the 2 equals r to the 2. This is r to the power of 2. Now remember this equation from real numbers. This equation, x minus x0 to the 2 plus y minus y0 to the 2 equals r to the 2, is exactly the equation of a circle. You should remember this from real numbers. That this equation, whenever we see this equation, this is equation of a circle. That the radius of that circle is exactly this number here, r. Not r to the 2, a square root of this number. Radius of this circle is r, and the center of that circle is x0 and y0. And exactly this is what we wanted to prove. We wanted to prove that this equation shows a circle with radius r. This is a circle with radius r. And the center z0. What is z0? Z0 basically is x0, y0. which we had here. This is a proof that whenever we have an equation like this, we can convert and write it in this form, and this is a proof that it shows a circle with radius r. But maybe you don't need to do this proof for yourself. Just memorize whenever you see an equation of absolute of z minus a number equal to a positive number, that positive number in the other side is the radius, and that number inside the absolute is the center of the circle. Now let me show you some more examples about this. For example, consider this equation. Absolute of 2z plus 3 minus 4i greater than equal, for example, 4. What this equation shows? Remember that when we have absolute of z minus z0 equal r, this is a circle. In this equation we have z, but here is 2z. So immediately we notice that to make this similar to this, we have to get rid of these two here. How? Simply divide left side and right side by 2 to make 2z equal to z, to get rid of that 2 here. So the first thing here is to get rid of that 2. So we divide both sides by 2. Then we have z plus 3 over 2 minus 4i greater than equal 2. And of course this should be 2i. We divided everything by 2. Now the other thing that we have to do is to factor a negative from this number here, because always we want to have z minus z0. This is very important. So we factor a negative here, then we have absolute of z minus negative 3 over 2 plus 2i greater than equal to. Now immediately we can say that this is center of our circle and this is radius of the circle. So we can graph it here. The center is at negative 3 over 2, which is negative 1.5. So we move 1.5 unit to the left, 2 unit up, 2i plus 2i. So if we suppose here is negative 3.2, we move up 2 units. So this is the center of 1, 2 units. So this is the center. Radius of our circle is 2. So here is 1, here is 2. We draw a circle with radius 2 with that center. The circle would be something like this. I am trying to graph a circle, but it's hard. Okay. Now please pay attention to this. This circle just touches x-axis here, but crosses y-axis at 2 points. Because this is less than 2, the radius of the circle is 2. So this is 2 units. This is up to here 2 units. 2 unit up, 2 unit to the left. This is radius of the circle. But this equation shows the points on the circle. Attention, we have greater than equal to. The points on the circle and the outside of this circle is the region that this equation shows. If it was less than equal, it shows the interior points of the circle. But because it is greater than equal number, it shows the exterior points, and because it has equal, also the points on the circle are parts of the region. Let me show you one more example. What about this equation? Absolute of z minus 1 plus 2i less than equal 1. or just less than 1. What about this? First, we factor a negative. Then we have 1 minus 2i less than 1. This is the center of the circle, and this shows radius of the circle. 1 minus 2i, 1 minus 2i is here. Radius 1, so with radius 1 we have something like this. Because it is less than, the points inside this circle is the region that this equation shows. Attention, only the points inside this circle are the points that this equation shows, because we don't have equal sign. Now let's move to the next question that here we have. Imaginary part of complex number z is greater than equal 1. Remember, complex number z is x plus iy. And then imaginary part of the complex number z is y. So basically this equation means that y greater than equal 1. If we draw real axis and imaginary axis, y greater than 1. If we suppose here is 1, y equal 1 is the point on this horizontal line here. So the points on this horizontal line is y equal 1. But we want to sketch the region that y is greater than or equal 1. All the points that are above this and also the points on this line are the points that this equation shows. So the points on the line and above this line are the region that this shows. What about this? Real of z less than 2. Again, we remember, when z is x plus iy, real of z is basically x. So this equation is x less than 2. X less than 2. Let's suppose here is 2. Less than 2 are the points in the left side of this vertical line. This vertical line is x equal to, but we want only x less than 2. So only the points in the left side of this vertical line is the region for this question. What about this equation? Absolute or modulus of z minus 4 greater than equal absolute or modulus of z. To answer this question, you have two choices. You can either convert this to an equation in the x and y, in terms of x and y, or you can think to the geometric interpretation of modulus or absolute of a complex number. First, let us start with thinking to the geometric interpretation. What is the meaning of this? Distance from point 4. So we are looking for points that their distance from 4 is greater than their distance from origin, because we don't have any minus anything, just we have absolute of z. So this absolute of z or modulus of z is the distance from origin. So we are looking for points, which here is z, for points z such that, for all points z such that their distance from 4 is bigger than their distance from origin. Let me draw the vertical and horizontal axis here, or real axis and imaginary axis. 4. Let's suppose 1, 2, 3, 4 is here. Origin is here. Now, think to points that their distance from 4 is bigger than their distance from origin. If you think about this point in the middle has the same distance from these 2 points. And because we have equal, this is part of the answer. Because the distance of point 2 from 0 is the same as distance from 2 to 4. The two distances are 2. This is 2 units, this is 2 units. And if we draw a vertical line here, if we draw a vertical line exactly at this point, let me draw with a solid line here. If we draw a vertical line here, the points that are on this line have same distance from origin and 4. For example, this distance is the same as this distance. But the points that are in the left side of this vertical line, for example, this point here, the distance from origin is less than the distance from 4. But we are looking for points that their distance from 4 is bigger. So, exactly the points that are in the left side of this vertical line are the answers. So, all the points that lie on this line and are in the left side of this vertical line are our answer, are the points that we are looking for. So the region is this vertical line and all the points in the left side of this vertical line. Let me explain this again here. Consider, for example, a point in the left side of this vertical line. For example, let's say we consider this point here. It is obvious that this point, the distance from the origin is the distance from 4 is this, which is obviously bigger than the distance from the origin. But we want a more concrete, better way to prove this. So here I want to give you a proof for this. To prove this, we start from this equation and we simplify this equation. We suppose z in the equation to be x plus I y. And we substitute this in the equation. So absolute of x plus I y minus 4 greater than equal to absolute of x plus I y. What is the definition of absolute or modulus of a complex number? Square root of real part to the 2 plus imaginary part to the 2. Before that, let me write the real part together, x minus 4 plus iy, and the other side, same equation. Now use the definition of absolute or modulus. Absolute or modulus of this complex number here is a square root of x minus 4 to the 2 plus y to the 2. And for the other side, we have a square root of x to the 2 plus y to the 2. Raise both sides immediately to the power of 2 to get rid of these radicals. Then we have x minus 4 to the 2 plus y to the 2 greater than x2 plus y2. Raise this bracket to the power of 2 or multiply x minus 4 by itself. X minus 4 times x minus 4 would be x to the 2 minus 4x minus another 4x plus 16. So basically it is x to the 2 minus 8x plus 16. So we have x to the 2. If you are familiar with the identity, you can use that identity instead of wasting your time for multiplying x minus 4 by itself. But we multiplied it by itself anyway. X to the 2 minus 8x plus 16 plus y to the 2 greater than equal to x to the 2 plus y to the 2. Move everything to the left side of this equation. If If we move everything to the left, we have x2 with x2 cancels, y2 with y2 cancels, and then we have negative 8x plus 16 greater than equal to 0. If we move 8x to the other side, because I want to make coefficient of x positive, if we move 8x to the other side, then we have 16 greater than equal 8x. If we divide both sides by 2, then we have x less than equal to, by dividing both sides by 2, x is less than 2. So, by simplifying the equation and rewriting the equation in terms of x and y, we got to this: x less than equal to, x less than equal to, x equals to is exactly this vertical line. Less than 2 is the left side of this line. So less than equal to is vertical line, and all the points in the left side of this vertical line. This is exactly the same as geometric interpretation. Now look at this. This is similar to the previous question, but the points are different. First, let us start again with geometric interpretation. Let us start with sketching x-axis, y-axis. One point that here we have is I, z minus I, so the point is I. Suppose I is here. And z minus 1, we suppose 1 is here. Imaginary axis is the vertical axis, and real axis is horizontal axis. That's the reason I goes in the vertical axis, this constant goes in the horizontal axis. Now we are looking for points that the distance from I is less than, so basically the points that are closer to I. So we are looking for points that are closer to I compared to 1. Again, if we connect these 2 points to each other, if we connect these 2 points to each other, this point in the middle has same distance from these 2 points. And it is part of the answer because we have equal sign. So this point, the distance from I is the same as distance from 1. But we are looking for all the points that their distance from I is less than the distance from 1. Now, if at this point we draw a vertical line, a line, not vertical, a line perpendicular. If at this point we draw a line perpendicular to this, I'm talking about this line. If we draw a perpendicular line here, the points on this line have same distance from these 2 points. For example, if you consider this point, the distance from I is the same as distance from 1. Now, the points that are above this line, for example this point, the distance from I is less than from 1. So, with the geometric method, now we know that the answer is this region. But probably finding the answer with this geometric method is a little tricky and a little maybe hard for some of you. Now let me show you how you can get this answer with the other method. So again, similar to the previous question, we suppose z as x plus iy, and we substitute this in the equation. If we substitute this in the equation, we have absolute of x plus iy minus I less than absolute of x plus iy minus 1. We group real parts together, imaginary parts together. If we factor I here, we have I times y minus 1 And in the other side, we have x minus 1 plus iy in the absolute. Based on the definition, we have a radical x to the 2 plus y minus 1 to the 2 less than equal x minus 1 to the 2 plus y to the 2. If we raise both sides to the power of 2, these radicals go away. Now let's simplify left side and right side by raising to the power of 2. In the left side we have x to the 2 plus y to the 2 minus 2y plus 1. In the right side we have x to the 2 minus 2x plus 1 plus y to the 2. If you don't know the identity for this, simply multiply x minus 1 by itself and you are going to get this expression easily. Now let's move everything to one side. I prefer to move everything from here to this side. If we move everything to the right, basically, what happens? x2 with x2 cancels because it's going to the other side, it's going to be negative. y2 with y2 cancels. 1 with 1 cancels. At the end, we are going to get negative 2x plus 2y greater than equal 0. Move 2x to the other side, then you are going to get 2y greater than 2x. Divide by 2, y greater than equal x. This line here is exactly y equal x. You are familiar with this line. Y equal x is this line. Y greater than x is the points above this line. If you think to a point here, this point, for this point, the y value is greater than the x value. But points below this line, like this point, the y value of this point is less than x. So y greater than x are the points above y equal x. This confirms that our solution with the geometric method was also right. Now look at this question. Imaginary part of complex number 1 over z is greater than 1. A little unusual question. It's not imaginary part of z, imaginary part of 1 over z. So first we have to divide 1 by z, and then we have to simplify to see what happens. So let us start with first finding what is 1 over z. We know that in these questions, we suppose z as x plus iy. To divide two complex numbers, we know that we have to multiply numerator and denominator by the conjugate of denominator. We want to divide this by this, and because this is a complex number, we have to multiply numerator and denominator by the conjugate of that. X minus iy times by x minus iy. So first I prefer to simplify this, then I'm going to find the imaginary part of that. Multiply numerator by numerator and denominator by denominator. If we multiply this by this, x plus iy times by x minus iy is simply x to the 2 plus y to the 2. When you multiply a complex number by its conjugate, always the answer is the real part to the 2 plus imaginary part to the 2, y to the 2. But if you don't know this, I have repeated this at least 10 times in my videos in complex numbers. But if you don't know this, if you multiply these two brackets by each other in a normal way, the answer would be x to the 2 minus I to y2. I to the 2 is negative 1, negative times negative would be positive, so finally you are going to get this. So, by multiplying the denominators by each other, we have x2 plus y2. And I prefer to write this answer in the form of x over x2 plus y2 minus y over x2 plus y2 times I. What happened from here to here? Because we want to find imaginary part of this, I prefer to separate the imaginary part and real part. We have to divide this by this. So x over denominator minus iy over denominator. And instead of writing negative iy over x2 plus y2, first we write the coefficient of I, which is negative y over x2 plus y2. Now, what is imaginary part of this? Attention, this is exactly 1 over z. What is imaginary part of this? Imaginary part is the coefficient of I, so this is imaginary part. So immediately we say imaginary part of x over x2 plus y2 minus y over x2 plus y2i is basically negative y over x2 plus y2. And we want this to be greater than 1. Now we have to work on this. Please pay attention. When you have inequality, you are not allowed to do any cross multiplication like equations because this is inequality. But if this expression that you multiply is positive, you are allowed only in that case to do cross multiplication. But in normal situation, you are not allowed to do cross multiplication. Be careful about this. But why this expression in denominator is positive? How I know this? Because x is raised to the 2. When something raises to the power of 2, another real number to the power of 2, we know that these are positive. So because we know that x to the 2 plus y to the 2 is always positive, we are allowed to do a cross multiplication here. Otherwise, it's not allowed. And what we have to do in that situation, we have to move one to the left and do a common denominator. But here, we use the simpler method, which is the cross multiplication. If we do a cross multiplication, what we get from this? If we do a cross multiplication, then we have negative y greater than x2 plus y2. So, from here to here, basically we can say we multiplied left side and right side by this, and we are allowed to do this because we know that this expression is positive, and when something is positive we can do this. Now let's move y to the right side and write this equation in the form of x2 plus y2 plus y less than 0. I am looking to write this in the form of x minus x0 to the 2 plus y minus y0 to the 2 equal a number, because I know that this is a circle. If you remember, we talked about this before in this video. And how I know that? I have to look for that because what I am seeing here in this equation is x2, y2. This reminds me circle. Equation of a circle. So, but how I can do that? x2 is the only term that we have with x, but y2 plus y, we have to do a complete square method here. We have to try to write this in the form of a complex, in the form of a square, complete square form. To do that, if you remember, to convert a quadratic expression like this to a complete square form, we have to add and subtract a number. What was that number, if you remember? The coefficient here is 1. Always we divide this coefficient by 2 and we raise that number to the power of 2 and we add and subtract that number. So here the coefficient of y is 1. We divide 1 by 2, 1/2. S square 1/2. 1/2 to the power of 2 is 1/4. So we add a 1/4, and to cancel that we subtract. So basically we did nothing in the left side. Just we added 1/4, we subtracted 1/4, and in the left side everything is the same. And we write the right side. Now this is basically, for x2 we write x2. This, if we consider this as a group, this expression can be written as y plus 1/2 to the 2. Again, where this 1/2 comes from? Half of this coefficient. Writing quadratic expression in the complete square form. This is the technique. And for that negative 1/4, what we have to do with that? We are going to move it to the other side. So then we have less than 1/4. Now, by looking at this, we can say that this is a circle. This equation shows a circle. In general, this shows a circle. But what is the center of the circle? Because for x we have nothing subtracted from x, so basically it is like x minus 0. So the center of the circle is 0. What is the y coordinate of the center of the circle? We have y plus 1/2. But in the standard equation, we have to have x minus x0 to the 2, y minus y0 to the 2 equal r2. And then x0 and y0 is the center. But here is y plus 1/2. But it should be minus. So y plus 1/2 is like y minus negative 1/2. So the center of the circle is negative 1/2. So the center of the circle, the coordinate of the point of the center of the circle is 0 and negative 1/2. What about radius? Radius is the square root of the number in the other side. So radius of the circle is 1/2. A square root of this number is the radius. So back to our question. This equation shows a region. That region is a circle. The center of the circle is 0, negative 1/2. 0, negative 1/2. If we suppose negative 1 here, negative 1/2 is here. 0, negative. Radius 1/2, so it should be something like this, a circle like this. It passes through negative 1 and origin, and this is radius 1/2. Let me draw a better circle here. This circle is something like this. Center is 0, negative 1/2, which is this point, and radius of this circle is 1/2. I hope by watching this video, now you are a little familiar with the regions in the complex plane. If you like this video, please subscribe in my channel and see you in the next videos.